All right. So first of all, I want to talk a little bit about the top question that you had here. And on the top question, there's one important word that it defines for you, but as I saw you performing things, most of us don't read things in its entirety anyway. All right, and this right here, this word up here at the top, regular hexagon. The definition's right beside it, but I'm pretty sure none of us read that top portion right there. Okay? And so whenever you see the word regular attached to any shape, it means that it has congruent angles and congruent sides. And what parts? All of them. It's not like two of them are congruent to each other, but it's all of them are congruent to each other. Can you tell me from our discussion yesterday, we dealt with one shape yesterday, right? Well, I guess you consider a circle a shape, but we dealt with one ridged, which means it can't bend, shape. What shape was that?
Triangle.
We did a triangle. Is there such thing as a regular triangle? It's not defined like that or termed like that, but is there a triangle at which all sides and angles are congruent? What is it? The equilateral triangle. It's just defined differently, right? Or just termed differently. And so there you go. And so what you were supposed to see as you tried to construct the one right there, it was hard to do, was it not? It was hard to draw it by hand and get it regular. How did we test it? You traced it on the patty paper, folded it over to see if the sides met on each other, right? And how many of you were able to do that on your own and it worked out? Yeah? Okay? So we got one person in here that I could actually draw it pretty good and get it over there. So I think maybe he's lying. All right. And so down here at the bottom, this is a way that you can construct or build this regular shape by using this tool. I'm going to also borrow that one for y'all so we can see it with both of them, okay? So these are the two tools that we've used all week. This kind of compass and this kind of compass. So we're going to refresh real fast before I start walking through it. The pointed end on this one represents the what?
Center.
The center of the circle. This one out here, the pencil is going to go where?
Radius.
Well, this pencil is going to go to the outside of the circle, correct? And what is the distance inside of it?
Radius.
That's the radius. Yeah, so it's going to create the radius. Over here, this one, what represents the center on this kind of compass? What do you mean by that?
Metal part.
The metal part, right? The metal center right here, this little bitty bead right here. And so how do I identify the outside of the circle with a compass like this? What pieces of this allow me to see the outside of the circle? The little dots. I put my pencil in the little dots, right? And so from the little dots to the center here is going to create the what of the circle? So go and say it. The radius. That creates the radius. All right? So understanding our tools is key. And so right down here, this construction is a little bit different in the fact of it doesn't have instructions. It has part of it performed, okay? And so what do you think is the first thing they drew? What would be the first step of that one if we were trying to give instructions to it? What's the first step you think? What did they do first, you think? What you think can't be wrong. Sitting silently can be wrong. I'm sorry? Okay, so we plotted a point. So you think they plotted all three of them? Okay, so which one do you think they plotted? Go ahead. Right, so they don't have any letters on it, right? So you're saying the middle one on this circle?
Yes.
All right, so I'm going to help us out. I'm just going to call that point A, right? And so what do you think the first step was? I'm just going to kind of abbreviate some of these. They're going to plot point A. That was probably what they did. Then what do you think they do for the second one? What do you think they did as the second step? So they put point A on the paper. So let's say they did that. What do you think they did next? Huh? They drew the circle. Do they have an exact length for the radius? They don't, do they? They picked one. All right, and so we're going to say draw circle A, and it's no defined radius. So basically what they did is they said here, and they went ahead and they just drew A like that, right? They just drew it. The dotted line means that it really didn't have to be there, or it could be ambiguous. It could be something that I'll pick or not pick. All right, so they did that. What do you think the next step they did was? So we got basically circle A on there. What do you think they did next? What do you think? Huh?
Point B.
Okay, so we're going to call, which one are you calling point B?
Whatever across from it.
This way or this way? You got two options.
To the right.
This one here?
Yes, sir.
Okay, so we put point B, but where would point B be at? Anywhere? It can be anywhere on what? Understand how I'm trying to talk you through so you start communicating the same way. Where's point? We plotted point B. I totally agree with you. That's why I wrote it. Where did point B go? Where did we put it?
At the edge of the circle.
Okay, so on the circle, because the circles don't really have edges, right? And so what we did is we drew circle A, and then we put point B on the circle A. You agree? All right? So what I want you to do is be able to walk these steps in your brain as you see them. It's a little different than having them defined out for me. I have to look at them and say, I think that's what they did, and I think that's what they did. And to be quite honest with you, that's highly more intelligent than following directions. That's how most of you play video games. You play it for the first round, and then you mess it up, and then you go back and you fix it because you learned that this is where the bad guy is, or this is what I have to do. That's how you do that. This is really more what your brain's going to operate than following directions anyway. Okay? And so what do we do after we plotted B? What do you think we did? What do you think we did? Okay, so we drew another circle. Drawing what circle? Because we have another circle there. How did I draw this circle here? What did I do? Come on, communication. Did you use the trace paper?
Yeah.
Okay, so what if we didn't have the trace paper? So she traced it on trace paper, moved it around.
Use the compass.
Okay, I used the compass. So but I can just draw any circle? Or is there anything that looks specific about those two circles?
Measure it.
They look the same. Same is a great word. What word in geometry is associated with the word same?
Symmetrical.
No, not symmetrical. Equal, and equal means what in geometry? Congruent. Beautiful. And so how am I going to draw a congruent circle to circle A? What has to be congruent so they're the same? The radius. And so if this is my radius here for circle A, how can I draw and get the exact same radius for circle B?
Put the point on.
There you go. So we're going to put the point on B and draw it, right? And so how does that go in my directions? You're going to put a point on A, and so our next one was draw circle B with radius AB. So I'm using the same value for radius AB to draw it, right? After we did that, they started. Now they have a line segment. Where did that come from? Where did the line segment come from?
From the center of the intersection of the circle.
Beautiful. The intersection. So we're going to put a point at intersection. Oh, I have eraser. Okay? And so we're going to call this one point C because it's already defined. Do I have another intersection point? Up here, right? We're going to call that point D. So if I went ahead and I connected BC, now I'm going to just start performing these steps. Instead of writing them all the way out, I just wanted you all to kind of see that you know what's happening. You know what order it's happening in once you start thinking about it. And so they connected those two. So what else do you think I'm going to do? What else am I going to connect? Go ahead. You can speak out. You don't have to raise your hand because I have to call your name then.
A and D.
Yeah. A and D. I'm going to connect that one.
B, B.
Okay. So I'm just going to go ahead and do what you say. I'm going to just draw some things lightly. If I connect that one, what else can I connect? Huh?
B and B.
This one right here.
And then A and C.
Okay, and you want to connect A and C, that's fine. What are we trying to create though? Okay, and that's not my hexagon, right? There's nothing wrong with that shape. They all have the same length. Why do they know that? Why do I know all of those segments have the same length? Are they the same value? Why? I keep interrupting you. I'm sorry. Go ahead. I think you're right. Just say it.
Or you get their radius.
There it is. That's the key word. They're the same radius, aren't they? All the way through, they're the same radius. And can a circle be drawn with different radius? Okay, so now, I don't have my 6 sides of my hexagon. I know that what looks like up here is fixing to go down here. So what do I need to do? I need to make it look like that. So, let's think about what we did real fast. I drew the initial circle. I put a point on the circle, and then I drew the other one using the same radius, and where the circles intersected, I drew a line segment. Can I draw any more circles? Which one? I can do it circle C. What do I need to have? Can I just draw any old circle I want? Has to have the same radius. So I'm going to make sure my radiuses are good, so all of them are going to go through A, are they not? So if I have C, and there's A, I put my point at C, I use the same radius length as A, and I drew the circle.
Which is 1.
Now, you don't have to draw the whole circle if you don't want to. You can draw where they cross because the intersection point was the key, right? So I have an intersection point right here. What point do we want to call that? We got A, B, C, D. We'll call that E. What am I going to do with that intersection point? There you go. Draw a line from C to E. So now I have 1, 2, 3 line segments to my, or 3 sides to my regular hexagon, correct? How many more do I need? Huh? Hexagon? If I have 3, how many more do I need? 3 more. So what I would like for you to do, what will my next circle come from? Huh? I could do it from D. Okay? So I want you to take, and I'm going to use this one this time. So everybody that uses this kind of device, you'll be able to see it. I'm going to put my circle, my metal end at D. And where does my hole need to come out at? Looks like about right there. Because I need to have the same radius as. See where my hole is right here? Because there's A right there, right? So I need to have the same radius from D to A, that is A to B, A to C, A to E. So I'm going to come down. Looks like that hole right there matches up. So from there, I'm just going to draw a half circle because I'm looking for the what? The intersection point, correct? There's my intersection point. What do we want to call it? A, B, C, D, E, F. I know the alphabet's tough. All right. So how many more sides do I need? I'll tell you why you're having an issue. Put some papers underneath it. Because your little point's sliding. You need some papers underneath it. Okay, where's my next circle going to come from? Huh? E. So y'all do that. Those of you that are sitting around looking, we're going to draw a circle at circle E. Go ahead and do that now. You don't have to draw a full one. You can do arcs like I'm doing. Go ahead. Don't sit there and stare into space at it. You need to try to do it now. So you're drawing a circle at E, and you should know what the radius length needs to be by now. So try that out. Okay? This is going to just keep running. I'm going to walk around, see if I can help some of you. Or you can utilize your partner. Okay? So have communication. That's fine. The purpose of this activity is you to be able to use the devices good. Good job, dude. You got power. Now, you got some things I can do. Yes, it's going to come out. You see the concept.
to know that I got this is that one, but I have some misses right here, so let's clean it.
That's not
You
kind
can
of
always
just
see the percent together.
right.
It should, that's a nice little bit.
Who's that put it on? D?
That's devices.
All right, so help her. You did a good job. It's going to kick on in just a minute. I'm sweating. It'll be cold in here, so. All right, how y'all doing? Y'all got that one drawn? The points are where the intersections happen, correct?
What, did you just draw any old circle here? Okay, what circle is that?
But how is the distance of it? From where to where? You gotta have a consistent radius, okay? So what radius should it be? All right, I'm gonna perform it. You can just check yours with me. I'm gonna draw a circle at circle E. Okay, I'll do this one with this compass. My radius needs to be the same radius from A, right there. I think that's still an issue some of us are having. You're just drawing a circle, any old circle, but it has to come from A. There's where it's going to be. There's my point of intersection. And there I have it. Right? How many sides to my regular hexagon do I have now? 1, 2, 3, 4, and 5. Can I draw the 6th one?
Yeah.
I can, right? I don't even have to draw another circle to draw the 6th one. But here's what I want you to do. So you can practice using this one more time. We're going to draw a circle from circle F. So I'm going to use this one again. Put my point there. I'm going to find out where my distance needs to be, because I need to have the same radius. Oh, I didn't have the right radius. All right, so there's F. There it is. And here's where it's going to go right there. I'm going to connect those. And there's my regular hexagon. What does regular mean? Remember, what did it mean? It's right here, right at the top of your paper. Right. So inside your box, there's a highlighter in there too, if you want to utilize that highlighter to highlight that top, just so you can know that I might need to remember that. Any questions?